we've now talked to the students about atoms. We've talked about what happens when atoms come together to make molecules. What we're going to do now is we're going to kind of take a wider view of this and actually see how this is all laid out. Kind of in science, we like to organize things. We like to put things in proper places. So what we're going to do now is we're going to talk about the periodic table, or sometimes called the periodic chart of the elements. Now, when we talk about the elements, we're talking about those atoms. Each of those types of atoms is an element. Now, we said before, there's about 118 of those different types of atoms, or those different elements. Now, when we look at the periodic table, this is kind of what we normally see. Laid out in 18 columns, 7 different rows, and it looks like there's more, but those bottom two, if you look at the numbering, they actually fit in 2 of the different rows, rows 6 and 7. What we're going to do is we are going to talk with the students about what these different elements are, what this chart means. Now, a little history of the chart. Prior to this gentleman, Dmitri Mendeleev, who kind of, credit where credit's due, he does look like kind of your prototypical mad scientist, but he was a chemist in Russia, and prior to him, people organized the elements in different ways. Some of them did them by their properties, some of them did them by, various types of organizations. But what he did is he made up a chart that kind of unified it all. Now, one of the things I like to talk to the students about is if you go to a grocery store and you look at the spice rack where all those spices are, that's kind of a way that we can think about the periodic chart. They are going this way and then they're going that way, and they're organized in a certain fashion. Well, what he did is he took the known elements of the time and he was able to put them in by categories. And here's actually a handwritten version of his initial chart. But what he was able to do is he also left gaps where things would wind up being that haven't been discovered yet. And so that is one of the things that made his chart kind of genius in a way. And so if we go back to this, we are back to our chart, we can actually start to put things in there. So what we're going to do with the students is we're going to talk about some of the planets, and we're going to talk about some of those elements. Now, what we want to do with the students is have them try and learn how to read the chart. So what we're going to do is we're going to show them some different things and have them actually go and investigate it. We're not going to tell them where they are, but they're going to investigate them. So the first picture we have up here is a picture of the sun. Okay? The sun mostly made of hydrogen and helium. So what we want the students to do is go to their chart and see if they can find hydrogen and helium. And on your chart, you're going to do the same thing. So you're going to take a marker, go ahead and highlight those two. And they are actually, look for the name. If you want to with the students, you can go into what those numbers mean. The number 1, 2, 3, 4, that's going to be the number of protons. If you want to get into the number with the decimal point, the atomic weight, you can. Depending on your students, you may or may not want to get into that right now. But one of the things we're going to do is have them see if they can identify those elements and see if they can find them on the chart. So in my case, I did helium number 2 and I did hydrogen number 1. But another thing we can do with the students to help them kind of relate to these different things is when we think about our, go back to my spice rack, well, those spices, if I'm going to cook something up, those spices are going to be my ingredients. Okay? And we can think of these elements as ingredients, and these ingredients come together to make different things. In our case, our formula or molecule. So if what I'm going to do is I'm going to have a little chart, and on one side I'm going to have elements and ingredients, and on the other side I'm going to have formula and recipe. So let's think about that for a minute. I have all my ingredients. If I'm making a cupcake would be flour, eggs, baking soda, chocolate. I don't really bake, so I don't know. But those are going to be the things. Those are my ingredients. Okay, standalone flour. That's one ingredient. When I put them together to make my cupcakes, well, I can call that now a formula or a recipe. So a formula is different ingredients that come together to make something specific. So on my chart here, I have elements and ingredients, and I have formula and recipes, okay? So, and my formula recipes, we can think of those as our molecules. But because I have hydrogen and helium, those are standalone. We don't have a recipe or a formula yet. But on our next one, planet Earth, as we look at that, one of kind of the important elements that is here on Earth is oxygen for us. So we're going to go through, we can breathe oxygen in the form of an O2, 2 oxygen molecules. Or we have H2O, which is water molecule. So go ahead and go to the chart, have them see if they can find oxygen, and they're going to highlight that in. So you go ahead and find oxygen, highlight that in. And then if I go back to my chart here, for oxygen, I have just one of my recipes. I have O2, so 2 oxygen atoms that come together to form an O2 molecule. That's what we breathe. So that's very helpful. So we are going to take this, and now we're going to move to another planet. Our next planet is Venus. And one of the striking things about the atmosphere of Venus is there's a lot of carbon dioxide on Venus. So we're going to have the students go ahead, go to the chart, see if they can find carbon. Look on your chart, see if you can find carbon, and we're going to highlight that in. Okay. Number 6 on my chart, oxygen was number 8. And we go back to my elements and ingredients here. We have added carbon now. But now we have another formula or recipe. We have CO2, carbon dioxide. All right. So we're now starting to add to this. We're going to do one more planet, and mine is going to be Mars. And in Mars, what gives it that striking red color is rust. So what causes the rust on Mars? Well, they have a high concentration of iron in the soil. So we're going to go to this and we're going to find iron. Now this can be a tricky one for the students because before we were able to kind of, H for hydrogen, O for oxygen, C for carbon. But now our iron is going to be Fe because instead of using the word iron, they use the Latin word for iron. Ferrous, I believe it is. And so we're going to look at that. That is number 26 on our chart. You're going to find that. The students find that, color that in. And then if we go back to our chart one more time, we are going to have now what's called ferrous oxide, which is iron oxide or rust. So we're able to do that. Now you can actually go around the room. You can have them find different things. A paper clip can be iron. You can use different types of things that are around you, use a penny to represent copper, whatever you want to do. But it's a great way for them to kind of familiarize themselves with the periodic chart. All right?